All right, good morning, A2 Trig. How y'all doing today? Today we're focused on 2.7. Now 2.7 is called piecewise functions. Now, so far with this chapter, every function we've been representing with a single equation. But not everything in real life calls for a single equation function. All right, sometimes there needs to be multiple functions with parameters in order to make it happen. So this video is very, very important, and we're spending 2 days on this topic. So please, please, please take detailed notes with this video, and then we'll do some application in class and do a few more examples. Then we'll have a second day to practice and take it a little further. So a lot of times they're going to be written in function notation like this. So f of x equals 2x minus 1 if x is less than or equal to 1. Then they'll give you a second function that's f of x equals 3x plus 1 if x is greater than 1. All right, and it'll say evaluate f of x when, let's say, x is 0 and x is 5. Now let's take a look at x is 0. Okay, so x equals 0. So is that less than or equal to 1 or greater than 1? We know 0 is less than or equal to 1. So we're going to use this equation here. Alright, so we're going to treat it the same way. F of 0 equals 2 times 0 minus 1. So 0 minus 1, so f of 0 equals 1. Again, we're evaluating it when x is less than or equal to 0. We use that function there. Now, if they asked us to evaluate it when x is 5, right, we know 5 is greater than 1, so we're going to focus on this function here. So when x is greater than 1, this function applies. So f of 5 would be 3 times 5 plus 1. So f of 5 would be 16. Alright, so these are the easy ones. Now, when I ask you to graph a piecewise function, things get a little tricky. Alright, so let's look at this one. F of x is equal to. We'll do 2 right now. There are problems that involve more than 2 equations or functions. We'll have 3x, f of x equals 3x minus 2 if x is greater than or equal to 1. And f of x is 2x plus 5 if x is less than 1. Now, again, remember, f of x in function notation is y equals. All right, so basically what we have is y equals 3x minus 2, okay, when x is greater than or equal to 1, and y equals 2x plus 5 when x is less than 1. Now, we're going to go back old school and make a t-chart to start graphing these. Once we get comfortable with them, I'll show you a little shortcut. But for now, I want to make sure we understand what's happening. So we make our little t-chart, x and y. Now, it's very, very, very important that we pay attention to this point. All right, that's our starting point. That's a very, very important point. So when x equals 1, we're going to substitute it in here. 3 times 1 is 3 minus 2 is 1. Now the next thing we need to pay attention is the inequality sign. It is greater than or equal to, so we're going to have a closed dot. Remember, when it's equal to, we have a closed dot. Now, we're focused on all values bigger than, greater than 1. So my next 2 values I'm going to choose are 2 and 3. You must choose values larger than 1. Now, you can go larger if you want, but those are going to be the 2 easiest to evaluate. So I have 3 times 2 is 6, minus 2 is 4, 3 times 3 is 9, minus 2 is 7. So let's graph these 3 points. All right. I have 1, 2, 3, 4, 5. I'm just going to go 5 in that direction. We got to go at least 7 up. Alright, quick sketch there, and let's plot these 3 points. So I have 1, 1, closed dot. This is the very, very, very important point. All right, this one here is an important one. Then we have 2, 4, and we have 3, 7. Now you always start at your first important point, and you go in the direction of the other 2 points only. Start at the important point, go in the direction of the other 2 points only. All right, now let's take a look at the next line. So again, we're going to make our t-chart. Let's do this one in red to distinguish the difference between the two functions. And again, very, very, very important point is 1. Now notice here it is just less than, so we're going to have an open circle to begin. And when x is 1, 2 times 1 is 2, plus 5 is 7. All right, then now we need to pick 2 numbers that are smaller than 1, less than 1. So I'm going to go 0 and -1, just the next 2. 0 is easy to evaluate. Keep in mind this is an open dot here, not a 0. So 2 times 0 plus 5 gives me 5. -1 times 2 plus 5 gives me 3. All right, so now let's graph this. At 1, 7, we have an open dot. Again, because that is less than. Then we have 0, 5, and -1, 3. And then again, we start at our special point, our very, very important point, and we go in the direction of the other 2. And that's your first piecewise function. All right, graphs at different values. All right, so when x is smaller than 1, we're paying attention to the red graph on the left, and when x is greater than 1, we use the graph on the right to evaluate. Again, we'll go into some application problems tomorrow to kind of explain why this is necessary. All right, so that's the first type of graph. Now, sometimes you won't always have 2 functions. Sometimes we can graph 3 or 4 at a time. For instance, let's take a look at this next one, and this is called a step function. All right, so we're going to have f of x equals, and we're going to have 3 if x is greater than or equal to 2 or less than or equal to 5. I'm going to have f of x equals 5 if x is greater than or, let's just go greater than 5 and greater than or equal to 8. And then let's go f of x is 7 if x is greater than or equal to 8 and less than or equal to 12. All right, now we're going to begin this the same way. Let's take a look at this first function here. So I have f of x equals 3, or remember, f of x is y equals. So if y equals 3, let's evaluate this function. So I have x and y. Now, with the step functions, I'm only going to choose 2 points. All right, and I'm going to choose my 2 endpoints. I'm going to choose 2 and 5. So when x is 2 and when x is 5. Well, y equals 3, so in either case it's going to be 3. We have a horizontal line, basically, right? So no matter where we are on that line, y is always going to be 3, no matter what our x value is. All right, and please keep in mind we have a closed dot, because we're less than or greater than or equal to and less than or equal to. So I like to put a little dot here and here to remind me. Closed dot, closed dot. Now let's do f of x equals 5. Again, y equals 5 in this case. And we're focused on the values when x is between 5 and 8. Again, my 2 endpoints, 5 and 8. We're focused on those 2 points. And when x is 5, y is 5. When x is 8, y is 5. All right, and then the last piece, f of x equals 7. So y is 7. My 2 main points are my endpoints, which in this case are 8 and 12. So at 8, y is 7, and at 12, y is 7, and these both are closed dots. And I made a mistake on my middle function. Notice I did not put open dot, closed dot. Here we have greater than, so at 5 we have an open dot, and here we have less than or equal to, so at 8 we have a closed dot. Alright, now let's graph this. Let's see what we're working with here. So I have my coordinate plane, and really the focus of this graph is going to be in quadrant 1. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so let's look at our first line. We have closed dot, at 2, 3, closed dot, 5, 3, closed dot, connect your lines. Alright, then we have 5, 5, 1, 2, 3, 4, 5, 3, 4, 5. We have an open dot, my mistake, open dot, and at 8, 5, 6, 7, 8, 5, we have a closed dot, connect your line. And then in the last function here, we have 8, 7, closed dot, 8, this was 5, 6, 7, and 12, 7, closed dot. And this is why we call it a step function, because it continues to step up. Now again, what does it mean? When x is between 2 and 5, we're going to evaluate it here. When x is between 5 and 8, we use this function here. And when x is between 8 and 12, we would evaluate it with this function here. Tomorrow we'll start with an application problem to explain why this is useful and what it means. And then we'll go into 2 examples to get some practice, and then you'll have another video tomorrow night. Alright, see you tomorrow. Thanks.